Hello students, welcome to Nagesh Karasgi Orchid School channel. Myself Priya teacher, and today I am going to teach you science subject for class 7. So children, we are discussing lesson number 13, motion and time. So in our last session we discussed about the concept of motion and also concept of speed and formula of speed. So today we will discuss our next point, but before that we will take a small recap of the whatever we learned in our last session, and then we will continue our lesson number 13. So see, in our last session we learned that what is mean by motion. So motion is the change in position of an object with time. So there are different types of motions. So they are, first one, motion along a straight line. So whatever motion in a straight line, that is called as a rectilinear motion. So for example, motion of car on a straight road. So in this picture you can see the motion of car on a straight road. Then second type, it is a periodic motion. So the example of that periodic motion, it is a motion of pendulum. Here in this picture you can see this is a pendulum. Then third one, circular motion. So example of this circular motion, it is motion of earth around the sun. Then speed. So we learned that what is mean by speed. So speed is the distance covered by an object in a unit time. So it is called as the speed of the object. So for example, if a car covers a distance of 100 kilometers in 1 hour and a bus covers a distance of 50 kilometers in 1 hour, then the speed of the car is more than the speed of the bus. So since the speed of most objects are not constant, so the speed is the average speed. So we discussed that whenever there is a motion of car or bus or bicycle, suppose sometimes you will go fast and sometimes you will go slow. So that is why the speed of these things or these vehicles will not remain constant. That is why we call it as a average speed. So if suppose that car is going to pass, or that capacity of that car or bus or any bicycle, then it is depend upon the time or that situation, condition, whatever is there. So what type of road is there, okay. So it is the, if there is a smooth road, then it will go fast, and suppose it is not, then it will go slow. So this happens. Because of that we say that not exactly that speed is calculated by this formula. Which formula is given here? Total distance covered upon time taken. So by this formula, whatever speed we get, that is not a exact speed, or that will not remain constant. That is why we call it as a average speed. Then next concept we learn that uniform motion and non-uniform motion. So what is mean by uniform motion? So uniform motion is the speed of an object is constant. Whenever there is a speed of an object remains constant, that is called as a uniform motion. And non-uniform motion. So what is mean by non-uniform motion? If the speed of an object keeps changing, it is non-uniform motion. So for this uniform motion and non-uniform motion, we will see a video, then you will get idea of this uniform motion and non-uniform motion, okay. So let us see a video.
Uniform motion and non-uniform motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. A body is said to have non-uniform motion if it travels unequal distances in equal intervals of time. For example, consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O, and after 2 seconds, it reaches position A covering a distance of 4 meters from the origin as shown. In next 2 seconds, it reaches position B covering a distance of 8 meters from origin, and in next 2 seconds, it reaches C covering a distance of 12 meters from origin, and in next 2 seconds it reaches D, covering a distance of 16 meters from origin. In this case, the car covers a total distance of 16 meters in 8 seconds with equal intervals of 2 seconds. It means that the distance covered by the car is directly proportional to the time. From this illustration, we can conclude that the car had travelled equal distances in equal intervals of time. So, this type of motion is known as uniform motion. Another example. Consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O and after 2 seconds it reaches position A, covering a distance of 2 meters from the origin as shown. It reaches position B, covering a distance of 8 meters from origin, and in next 2 seconds it reaches C, covering a distance of 10 meters from origin, and in next 2 seconds it reaches D, covering a distance of 16 meters from origin. In this case, the car covers a distance of 16 meters in each 2-second interval. From this illustration, we can conclude that the car had travelled unequal distances in equal intervals of time. So, this type of motion is called as non-uniform motion.
Then we will see our next point, which is measurement of time. So, let us continue discussion of this measurement of time. So, time is measured by using clocks. So, we discussed that in our ancient time, our ancestors were using different types of clocks for measurement of time, but these clocks are not giving us a exact time or accurate time. Okay. So, for accuracy, so modern human made these types of clocks. So, here you can see in this picture there are different types of clocks here. So, this is a digital clock. Okay. So, this one, so 12:58, 10:26, these clocks are showing the time in digital clock. So, time is here you can see this, these are wall clocks, and some here we are using for wrist. Okay. So, these are called as a wrist watches also. So, this is type of wrist watch, then this is the table clock, or this is the digital, and these are wall clocks. So, these types of clocks we use in our day to day life to measure time. Then clocks and watches make use of periodic motion. So, whatever motion is there, so this motion is called as a periodic motion. So, why this is called as a periodic motion? So, let us know about this. See, this is a simple pendulum. So, we know a simple pendulum has a small metallic bob suspended from a stand by a thread. So, here you can see a picture of, or sorry, image of a simple pendulum. So, this is a diagram you can say, or it is a image of simple pendulum. So, a simple pendulum, here you can see this is a stand and this bob. So, whatever circular structure is there, that is called as a bob. So, it may be of metallic, it may be of, but whenever there is a original simple pendulum is there, that is made up of a particular metal. But you can make this type of simple pendulum, or in model you can use any plastic balls or paper balls like this. Okay. So, which is having a particular weight. So, you have to make like this. So, this bob is connected or hanged to this stand with the help of this thread. So, this is nothing but a thread. So, any type of thread you can use which can carry this weight of this bob. So, that you have to take here. So, if the bob is taken to one side and released, suppose this bob you taken to this side, okay, left side, or you can say a right side, and released it. So, after releasing it moves to, and that motion of the simple pendulum is called as a periodic motion. So, it keeps moving. So, if suppose you taken to left side and then you released, then it will go to the center again and then it will go to the right side. Then for a while it will do this movement continuously. So, it will repeat this movement though you are not releasing or you are not holding. Okay. So, then it is also keep its movement. So, that type of movement or that type of motion, it is called as a periodic motion, or also that periodic motion, it is called as a oscillatory motion. So, here you can see the whatever this situation is there. Okay. So, in this situation it is at the center. So, this bob is not moving to left also and not moving to right also. So, it is a stable here. So, this point it is called as a O, and when it is going to left side, then it will call as a, and here when it will go to the B, when you will release and at which point it will release here to the right side, that is called as a B point. Okay. So, movement from A to O, from then O to B, then again B to O, O to A, this motion it is called as a periodic motion or oscillatory motion. So, oscillation. So, when the bob moves from the mean position. So, what is the mean position? See in this diagram. So, this is a mean position here. So, when the bob moves from the mean position, this is at the center, okay, or this is at the average place. That is why it is called as a mean. So, at the center, when that bob is at the center, that is called as a mean position. So, that mean position it is known as O. So, that point it is we are showing as a O point. Then position O to A. So, if this bob is going to move from mean position to the A, so A is it is called as a extreme position. Okay. Whenever that bob is going to move as possible as to its left side, then it is called as a extreme position. Then again that O point or that bob is going to move as possible as to its right side, then it is called as a extreme position. So, from this center or from this O point, this bob can move as possible as to its left, as possible as to its right. Okay. So, these position. So, at point which point it is going to reach here, whatever possible point is there, whatever possible place is there, that place it is called as a extreme position, and that is here A, and this, to this side it is called as a B. So, both these are its extreme position. So, it's these are bob's extreme position. So, it is called as a one oscillation. So, when it is called a one oscillation or one periodic motion, we will see here whatever it is given, when a bob moves from the O. So, from mean position, when that bob is going to move to A, then again from A to B and from B to O. So, this is the one oscillation it is called. It means that from mean point again it is going to move to A to B and going to come to the O only once, then it is called as a one oscillation. Or one more possibility is there, when the bob moves from one extreme position. Suppose this bob we are going to measure it from this point. Which point? From extreme point. Suppose that from extreme position A, that bob is going to move to O, then to B and again to O, and then again it have to reach to the A point. Then we can say that one oscillation is completed. Okay. So, hope you understood. It means from which point that bob is going to move, again it should have to reach to that point only from where it starts its motion. So, that is called as a one oscillation. Okay. So, though it is moving or it is calculated from A point, so it should have to reach once to A point, or it will start from O point, then it should have to reach to the A point once. So, that is called as a one oscillation. Or we can also say, see if suppose that a bob is going to move from B or from extreme position B, it should have to move from B to O, O to A, and again to O, A to O, and O to B. So, this is the first, or this is the one oscillation. So, either it is moving from A, so it should have to reach to A again, then either it is going to move from B, so it should have to reach again to B, or if it is going to calculate it from O or mean position, then it should have to reach from O to A to B, B to again the initial point, which is the O or mean position. So, this is called as a one oscillation. Then time period. So, the time taken by the pendulum to complete one oscillation. So, whatever time is needed there to complete this one oscillation, it is called as its time period. So, whenever that bob or this pendulum is going to complete one oscillation, that time is called as a time period. Okay? So, hope you understood these concepts, oscillation and time period. Then in your textbook, one activity it is given to measure the time period of a simple pendulum. So, as I told you that simple pendulum, it is made up of any metal, okay, that bob of that pendulum, it is made up of any metal. But here you can make this pendulum at your home also, and also you can see how this periodic motion done here with this pendulum, and also you can measure one oscillation or whatever oscillation can be possible with one released bob, okay, one release of that bob. So, here it is given, set up a simple pendulum. So, with the help of any thread or any plastic ball or with any paper ball you can make at your home, and that bob you have to tie with this stand. So, you can use your scale from your compass box, or you can use a stick also. Okay. So, with a stick or that scale or whatever that flat structure or stick like structure you can use, and you have to tie this whatever length of that scale or whatever length of that stick is there, you should have to measure it, and exactly center, at the center you have to tie this bob. Okay. So, whatever bob you are going to make, so that bob you should have to tie at the exact center of that scale or stick, whatever you taken there. Okay. So, at the center you have to tie this bob with the help of your this thread. Then a simple pendulum with a thread of length about 1 meter. Suppose it is given a 1 meter. So, whatever length of this thread, it will be 1 meter. So, length of this thread, it will be 1 meter. Move the bob to one side and release the bob. So, what you have to do? You have to move this bob from A to one side. So, any one side. So, first you will take any one side, then you have to name this point A. Then whenever it will reach to the second, it will, you have to give it to B. Then measure the time taken to complete 20 oscillations. So, you have to measure how many 20 oscillations you should have to measure, whatever time required there or you observed it, you have to write there, and you have to use a stopwatch. So, in your mobile you are having a stopwatch. Then stop clocks are also there, some students may be having stop clocks. Then record the observations in the table. Repeat the activity 3 times and record the observations. Find the time taken for one oscillation. So, the time period is nearly the same in all cases. Suppose you will done this activity at your home, then you will find that whatever time period is there. So, if you are going to do this 3 times, 2 times, 1 time, then every time whatever oscillation is there. So, that for one oscillation, whatever time will you observe, that time period, it is called as a time period. So, that time period you will observe nearly same in all cases. Okay. So, you have to do this activity at your home. So, and whatever table is given here, you have to complete this. So, series number, time taken for 20 oscillations. So, you have to measure time for the whatever time was is there for 20 oscillations. So, first you will do, then you have to mention here, then time period you have to write here, then second time you have to do, then third time also you have to do. So, you have to complete this table here. Then next, units of time and speed. So, whatever units of times and what are the units of speed. So, in our last session we discussed what is the formula of speed, and also we discussed what is the unit, also I told you. Okay. But here you will see the basic unit of time is a second. So, we measure time in a second. So, this is the basic unit. Okay. So, basic, it means from which you are going to count this. So, you can see the seconds are the smallest one. Okay. So, smallest unit also you can say here. So, the larger unit of the time are minutes. So, basic or smaller unit, it is a second, and the larger units of the time are minutes. And also after time you can measure time in hours also. So, this is the lower, then medium we can say minutes, and also you can see larger, and then hours are also the larger units. So, the basic unit of speed is meter per second. So, what is the unit of speed? It is the basic unit of speed is meter per second. Here you can see meter per second. So, whenever you are going to write unit, so you have to write with small, okay, smaller units. So, distance, here it is meter per second. Then a larger unit of speed, it is a kilometer per hour. So, kilometer is the larger unit of distance and hour is the larger unit of time. And here you can see meter is the smaller unit of distance and seconds are smaller unit of time. So, like this you have to write the unit of speed meter per second and unit of speed again in larger way, that kilometer per hour. So, ancient time measuring devices are some ancient time measuring devices were sundials, water clocks and sand clocks. So, here you can see this is nothing but a sundial. Okay. This is a water clock and this is a what it is, sand clock. Okay. So, these are the three ancient clock you can see here. These were used to measure time by our ancestors. Okay. So, hope you understood. Now, here also you can see the sundial, how that exactly sundial looks like. This is a sundial, this is a water clock and this is a sand clock. Then measuring speed, we discussed that the measuring speed, the speed of an object can measured if we know distance and time taken to the covered that distance. Okay, we discussed last session, if a car covers a distance of 100 kilometers in 2 hours, then the speed of the car is, distance is equal to 100, time is needed or taken 2 hours, then speed is equal to distance upon time, it will be 100 upon 2, it means 50. So, that speed of that car, it will be 50 kilometer per hour. Then if we know the speed of the car and the time, we can find the distance covered by it. Distance is equal to speed into time. Suppose if it is given speed and time it is given, then you can find a distance. And also if we know distance covered by the car and the speed, we can find the time taken. If suppose distance and speed it is given, we can find time also. Though this formula it is about the speed is equal to distance upon time, but if suppose any two quantities or any two factors are given here, whatever distance or time or speed, any two we should have to know, then we will calculate or we can find out third one. Okay. So, third factor, whatever it is, speed, distance or time. So, hope you understood what are the units of speed and time. So, we will take a recap what we discussed in our today's session with the help of a video.
Hello children, today we shall learn about time and motion. You know, from the moment we get up in the morning until we sleep in the night, we have to do all work as per time. You get up at time in the morning, get ready in time, catch your school bus, reach school, come back home, do homework in study time, play at your favorite playtime. All these works you do in time. Have you ever wondered, in old days when there was no clock or watch, then how could people manage all their work in time? Those days, time was calculated by periodic events such as sunrise, sunset, etc. The time between one sunrise and the next was called a day. 1 month was calculated from one new moon to another. A year was fixed as the time taken by the earth to complete one revolution of the sun. Correct, kids? And some instruments were also made in those days to measure time, like the sundial, water clocks, sand clocks, etc. But none of them were accurate. We have different types of clocks to know the time with greater precision now. The working of clocks is rather complex, but all of them make use of some kind of periodic motion. One of the most well-known periodic motions is that of a simple pendulum. So what is this periodic motion? As we learnt in the previous video, any behavior that repeats itself at a fixed interval of time is called periodic. A simple pendulum does oscillations, that is to and fro motion at a fixed interval. This periodic motion of pendulum is called oscillatory motion. Remember, as we saw in the circus video, how those trapeze artists were moving in the air like a pendulum? So the movement of those trapeze artists in a circus is an example of periodic motion. So what is this simple pendulum? Like you saw in the circus, that a swing was suspended in the air on a rope. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of a periodic or an oscillatory motion. The pendulum is said to have completed one oscillation when its bob, starting from its mean position O as given in here, moves to A, to B and back to O. The pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position B and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. Galileo, who was an European scientist, was the first to examine the unique characteristics of the pendulum that could be used to measure time. It is said that once Galileo was sitting in a church, he noticed that a lamp suspended from the ceiling with a chain was moving slowly from one side to the other. He was surprised to find that his pulse beat the same number of times during the interval in which the lamp completed one oscillation. Galileo experimented with various pendulums to verify his observation. He found that the pendulum of a given length takes always the same time to complete one oscillation. That is, each pendulum has a constant period. This observation led to the development of pendulum clocks. So the length of the pendulum determines its time period. So if the clock is running too fast or too slow, the length of pendulum can be adjusted slightly, but the weight of the bob does not affect the time period. As we know, pendulums have.
Okay children, hope you understood what we discussed today. So, measurement of time, we discussed measurement of time, and also we discussed that how pendulum is there in clock works. Okay. So, our next point we will discuss in our next session. Today we will stop here. Okay. Thank you.